diagnosing vibration and noise conditions. All right, don't think about this right here. During a neutral coast down test, a vibration remains the same. All right, now you got see what you're going to do whenever you got some kind of vibration. You got to determine to begin with. I want to know what the frequency of the vibration is. And what do I mean by that? A wheel balance is going to feel different from a drive shaft. See, as a torque converter is going to feel different than all those. And when I went to this school up there at Ford, he made some vibrations that we had to go find. Y'all would like that, wouldn't you? Make some vibrations, you got to go find them. That'd be cool.
You do it.
They have vibration analyzers for this kind of thing, and you're supposed to look at the frequency of the vibration, and you can tell at a particular engine speed and road speed and all, everything is operating at a particular frequency. And if you got a frequency analyzer, which we had in the class, you could actually tell what the frequency of the vibration was, and you put a little vibration sensor on something that was bouncing, which would be like your end of your sun visor or something like that. And it was actually designed to pick up the frequency of the vibration. And you could actually start tracking that and tell if it was going to be something like that. Okay. But you got to start with attempting to define the complaint as clearly as possible. And what does that mean? Branden? Defining the complaint as clearly as possible. Have you ever had anybody, even in here, have you ever had, you really don't know what you're supposed to be working on because they didn't explain good enough what it was you were supposed to be doing. Right? It's extremely important that our service advisors find that. We got to get as many details from our customer as we can when they bring the vehicle in for service. Now, sometimes you may have to talk to the customer if the and there are places that don't like for you to talk to the customer. They need it if they've got a competent service writer. The service writer will give you really good information.
And Ford don't like that, and they don't have a very good service writer.
Yeah, so I mean, if they don't have a good service writer, and they won't let the technician talk to the customer, then that they're shooting the thing's going out in flames before you even start.
Yeah,
you know what I mean. Now, details such as whether the condition is a noise or a vibration, or whether it's heard or felt, or what circumstances are associated with it. Is it cold? Is it hot? Is it raining? How fast are you going? Do you hear it when you're stopped? Do you hear it when you're slowing down? This kind of thing. This girl that I used to drive to Port Arthur, there's dregs in there, but they won't hurt you going back.
They're what?
They're dregs. That's basically where the filter folded over and the coffee grounds went into the coffee. That's all it is. It's not ants like you drank before.
I know.
Okay. Yeah, he drank a bunch of ants one time. I told him, hey, they eat chocolate-covered ants in the military. But anyway.
Bad thing is he drank too.
I drank ants too. But anyway, what I was going to get at was this girl called, and she would say, Richard, my car, what am I supposed to do with that information? You know what I'm saying? So I say, okay, Cindy, you're going to have to tell me more about the car. It was the car that we were maintaining that she went to pick up stuff for the company for. It was a 15-mile drive up there and back. And she said, well, I put my car in gear. It goes, now. What am I supposed to do with that? You know. So, and then she'd call me and say there was a bird that hit my windshield going 80 miles an hour and broke it. I said, man, that was a fast flying bird. You know. Anyway, so we want to, there's actually a data sheet that's published some places that you can, fill out about that and talk more about that. With a detailed description of the problem, you can go to the next preliminary step, which is the road test. Remember what we did yesterday? What were we doing yesterday? He missed out on it. We were looking for a noise, weren't we? Okay, you missed out on it the first time around because there was not enough room in the car and you were too big. All right, so, but what we did was we drove the car. We actually connected our little wireless microphones to the four corners of the car, and we remembered where we put them. Where did we put them? One was where? Where did we put number one? Right front. 2 was right rear. 3 was left front. 4 and 3 was super noisy. It was like, now that car was so much better that it was not even any comparison to the way it drove before. But I could still hear something when I drove it. I could hear a very mild thing there. Right? Okay. All right. Test 8.
When we going to do ever.
All right. Okay, you guys pay attention because it's pretty important. An important objective in attempting to isolate the condition to specific circumstances and obvious components. In other words, stuff that's obvious, like wheel balance. Now, you had one that was vibrating, right? Your wife's car. You drove down the road, and it would just try to put you to sleep. And you were quick enough to figure out real fast what was causing that, and what was it?
It was the mud, about an inch of mud caked inside the rim.
Okay, so you cleaned the mud out of the inside. And that is an obvious component. That's right. Now, let me tell you this. If there's some kind of a vibration, and it's packed with a bunch of mud up in the rim, and you don't clean that out first, then you're not really doing good. You know, clean the doggone mud out of the wheels first, and let's see what it does then. And I've seen that where you just wash the mud out of the wheel and everything's fine. That's all you have to have. Okay? Now then. Okay, the first is to use the information from the repair order to reproduce the condition. If they say it's happening at 40 miles an hour on a smooth road, you find a smooth road and you hit 40 miles an hour and you feel for it. See what I'm saying? The second one is to try to isolate the vibration or noise to a specific location. Where is it coming from? Is it coming from the right front? Is it coming from the left rear? Or is it the whole dadgum car shaking? Now, one time we had one that sounded like a noise coming from behind the instrument cluster. It was a Ford Mustang. And it belonged to an old guy that had been a fighter pilot in Vietnam. And he was a real meticulous guy with his Mustang. And he was an older man, you know. But the thing about it is, we were driving that thing and we were hearing something from behind the doggone instrument cluster going, you know, buzzing.
What year on Mustang?
It was like a 96, 95, something like that. And, you know, round body style.
GT?
And, yeah, it was a hot rod. But the point is, it sounded like behind the instrument cluster, so they gave it to me. So that, you know, instrument cluster, electronics, blah, all this kind of stuff. And I realized that, wait a minute, you could take a coat. I mean, a shop foreman working together a little bit, and you could hold that coat up in front of your face, and you wouldn't hear it anymore. It wasn't coming from the cluster; it was coming from the windshield.
It was loose?
No, windshield wasn't loose. We actually taped all of the chrome and everything, the strips around the windshield, any chrome strips around that. We put masking tape over those just to see if that would make the noise go away, and that way we know what we had to do. Nothing changed that. And so we worried with it, and finally the old guy said, well, I got to go right now. I will come back later, you know, and all that. So he came back, and he says, I found out what that was. And I said, what was it? And he said, I had my hand. Now, this guy was a pilot. He was a fighter pilot, and he thought about air movement and all this kind of stuff. He was pretty smart. But he said, I had my hand out the window, you know, how you just kind of prop your finger up, you know, with the windows down a little bit. He says, and I could feel that on the tip of my finger. And he says, and I moved my finger around while it was there until I was pointing right at it.
What was it?
And so he said, so I stopped the car, and I got here behind my finger, and I was looking at the edge of my bug shield. Yeah, and he says, so he gets little aluminum strips with Velcro, and he stops his bug shield from vibrating, and all that noise went away. But it was given to me for a noise that was coming out of the instrument cluster. Go figure. And it sounded like that's where it was coming from. See what I'm saying? These noises will drive you up the wall, and so don't be surprised if they tell you a noise. Okay. Third attempt is to isolate the condition to specific circumstances and obvious components. Does it occur during braking or steering? Right? Does it occur during, various engine speed conditions or wheel speed related? Okay, now this is what I want to know about. I want to kick the thing up in neutral. Sometimes, if I'm listening to a noise or I'm trying to feel a vibration or something, I'm going to throw it up in neutral and I'm going to switch the motor off. With it in neutral, coasting down the road, do I still feel it? Okay, let me ask you this. If I don't feel it with the engine switched off, it's probably going to be torque and or engine related, right? You know what I'm saying? Like you got to have a torque. But if it's still doing it, you know, then I say, okay, what is still moving when it's in neutral at that speed?
Drive shaft. Drive
shaft's moving, whole rear axle's rotating, the wheels, anything out there. See what I'm saying? Front wheels are moving too.
Yep.
Got that? All right, so we're going to isolate. Now, third objective is really important because it's going to provide direction for troubleshooting. It's going to tell you where to go. So, knowing a condition is vehicle speed rather than engine speed related allows you to attempt to match the frequency of the condition with calculated frequencies of wheel speed related components. All right, now, how would I determine what the circumference of the tire was? Now, wait a minute. You're going to have to, huh? Well, no. I mean, the circumference. How far around is the tire? How many times does it roll in a mile?
Oh. You will multiply the tire diameter by pi.
Now, if you're not a math whiz, you can put a piece of masking tape on the floor and on the tire, and you can roll it until that masking tape comes around and touches the floor again, and put another one and just drag your tape measure. All right, now, how far is a mile?
How far is the mile?
Yeah, 4 feet. How many feet?
5,728.
No, 5,280.
280.
Okay, so I've got a tire that's 10 feet in circumference. And not diameter, but circumference. Did I say diameter earlier? I didn't mean to say diameter. I said circumference. All the way around. Okay, so if I've got one that's 10 feet in circumference, how many times does it roll in a mile?
A bunch.
Huh?
A lot. Would it be 528?
Listen to him. You guys learn from Branden. He knows the math. You take a zero off the end of it. Brandon's always done that ever since I had him in here in high school dual enrollment. If I asked a math question, he usually had the answer. It depends on how much. It depends on whether he's focused on what I'm saying or not, though. All right, now he knows the answer. It's just that sometimes he has trouble with it. But the fact is, he got it right. Okay, so you got 528. You know for doggone sure. Okay, now let me check. You know how much is 1 hertz?
1 hertz?
Yeah,
I don't know.
1 time per second. 1 hertz is 1 time per second. 2 hertz is twice a second. When you're talking about megahertz on your radio, that's the frequency of the signal, right? Megahertz is FM, kilohertz is AM, right? And megahertz is what happens when you fall in a canyon or something. There's briars down there. Megahertz, it hurts a lot. That was a joke. All right, now here we are looking at this vibration. I'm just trying to get you to think like a vibration checker, right? All right, so let's say that you manage to analyze this vibration and you determine, and most of the time we're doing this just thinking about it. Say, that feels like a wheel. Or if you got a vibration that's real high frequency and comes in and out with speeds, that's usually a drive shaft vibration. You remember early on when we put a drive shaft out of balance and you guys felt it? Remember all that? That's why you got to be able to pull that out. So, but anyway, here you are. Now, if you weren't able to duplicate it, how many of you have ever worked on one where you couldn't see what was wrong with it? I mean, where you didn't even see the problem, right? If you're not able to duplicate it on the road test, consider the fact that there may be circumstances that did not appear on the repair order. Stuff the customer didn't say, okay? The condition may be load-induced. One time, this Johnny, I've heard this guy telling me, he says, I had my pickup truck, it was a Jeep Comanche, and when I loaded it with feed and I would drive it, I would hear a tick, 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 tick noise from the back. And he says, and it turned out that he took it to the shop and told him when he loaded it with feed, he'd have that. Well, he took the feed out of it, it wouldn't do it. Well, the park brake cable, the park brake cable on that one was routed in such a way that when you loaded it with feed, it would get over there and the tire weight would hit the park brake cable, and it would make a tick, 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 tick noise. And so the shop foreman had a bunch of us getting the Jeep Cherokee, which was the same vehicle, but it was, I just remembered what he told me. And we were driving, and we was all sitting in there, and we hear tick, 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 tick. And so Johnny says, Johnny, stop the truck, stop the truck. And so he stopped the truck. And so I got out, I looked under there, and I could see where the tire weight had been hitting the park brake cable. So I got a spring that was hooked to the park brake cable, moved it over so it was holding it away from the tire. And then we drove it, and he goes, you must have run into that before. And I said, nope, never did. If you figure it out quick, they're going to think you've seen it before. If you hadn't seen it before, then that means that you're smarter than them. You see what I'm saying? Or that's trying to make you think I was anyway. All right, now then, the condition might be related to operating temperature or ambient temperature. It may do it on a cold day, but not on a hot day, or vice versa. The vehicle system dimensions and locations change. A lot of stuff swells and, expands and contracts. But you may need to talk to the customer or have them go with you. One time this guy got a Volkswagen place in there, and he had a cassette recorder. And he goes, I hear this sometimes. And he hit play. You can't really tell anything about that, from a tape recorder. Usually, voice recorders nowadays are better than they used to be. Sometimes they'll give you an idea if it's something you heard. Okay, now that you've used your road test to narrow down your circumstances, the next step is to look for any obvious causes related to the circumstances. If the vibration occurs at higher speeds, look at the wheels for missing weights or mud or whatever. That's what we talked about earlier. Don't overlook the basics. You hear me? Don't overlook the basics. Don't sit here and shrug your shoulders. You know what I'm saying? You know what employers want? And you know this. Everybody's worked for anybody knows that they want somebody, and I told Chelsea this morning. They want somebody that they can say, go get this done, and they want to know it's going to be done. They don't want you to come back bothered them, right? Okay. Now then. You need to look at equipment like bug shields, CB antennas, running boards, roof racks, all that stuff. Anything that you see that's liable to be causing it, issues in the wind. But the crossbars on a roof rack can be a source of wind noise when they're positioned at the front of the vehicle and not in use. In other words, if they slide them to the front of the vehicle and not using them, it can be a problem. So make sure to pay attention to where the crossbars are on the top. The things that hold the. All right, that affects the condition. All right, so one thing that can save you time is TSBs. So if you pull a TSB and it tells you right where to go, then my word, how handy that is. So now then, you got this. Yesterday we used this thing. No secret that you got to have sophisticated tools and techniques sometimes, and that's going to be true for vibration and noise. So you get a chassis ear, which is what we used yesterday. It has clamp-on sensors, and there are miniature microphones connected to the switchboard and the headset, which is what we used. All right, we position them at various locations on the body, chassis, or engine, and you switch them. You can isolate a noise to a particular area. And when you're using it, you got to keep in mind the sound is amplified. You're not necessarily looking for high levels of noise, but differences from known good components. Now, what did we do yesterday? We listened to one wheel, another wheel, another wheel, and another wheel, and wheel number 3 was loud as all get out, and the rest of the wheels were fairly quiet. Now, you have to separate the static, on the wireless microphones from the other, and we had a little issue with that. You also got an engineer. You know what an engineer is? This is not somebody that drives a train. This is an engine ear. Have you used one of those?
An engineer?
Yeah.
You talking about the stethoscope?
Yeah. Well, engine is this electronic stethoscope. It's kind of like what we used on the car, but it's got really nice headphones and a curly cord, and you listen to it like that. See? Now, this thing we had yesterday was cool as all get out because it had a speaker on the little box. It had no cords or nothing. You just turn on the speaker, and everybody in the car can hear it, right? Okay, so your electronic vibration analyzer is something else, and it's got to cost about $5,000, depending on which kind you buy, $2,000 to $5,000. That's going to tell us the frequencies and all that. Okay, let's look at some of these questions here now. During a neutral coast down test, the vibration remains the same. Of the following components, which is the most likely to be the source of the condition? Neutral coast down. Is it liable to be the torque converter, engine accessories, crankshaft, or tire and wheel? Now, wait a minute now. That's a neutral coast down. Got to be tire and wheel, right? That's the way I'm thinking. During steering input test, let's drive it through wide turns with the vehicle in gear, the noise gets worse. Think about that now. Wide turns with a vehicle in gear, the noise gets worse. So, which is that probably going to be?
The prop shaft, is that...
Well, the prop shaft is basically, when they talk about the propeller shaft, that's the drive shaft. That's going to the rear end. Now, this is going to be a wheel bearing issue. That's what we're talking about here.
I thought the prop shaft was a turn and planes and stuff.
Yeah. Now, let's talk about our vibration analyzer. We got a little question from that now. And it's silly. If you ain't got a vibration analyzer in your hand, you're not going to know the answer to this. So I'm just going to go ahead and give it to you. Which of the following can you do using the keypad on the electronic vibration analyzer? Freeze readings, record readings, select ARB inputs. Well, that ain't really too hard. All of the above. That's number 3. Which of the following tools will be the best to use to balance a drive shaft?
Prop shaft.
Drive shaft, prop shaft, same thing. When you hear prop shaft, think drive shaft. Electronic vibration analyzer with a strobe light. All right. Got it?
What's the strobe light do?
Huh?
What's the strobe light do?
Well, what you're going to do is you're going to have this strobe light hooked up so that it's actually connected to something on the car, and you've got little marks on whatever it is you're checking, like a tire or wheel or drive shaft, whatever. And this strobe light, every time that vibration happens, the strobe light will flash, and it gives you an idea of where you need to put your weight. See, it's kind of like using a timing light, but your input's going to be the vibration, right? Okay, now this is really good. Branden, get your math whiz ready. A truck with a tire size of LT21585R16 is traveling at 60 miles an hour. What's the first order frequency of the tire and wheel at that speed? And that sounds like a confusing question or what?
It is.
Now, what is a first order versus a second order frequency? A first order frequency means the tire's got one bump on it. A second order frequency means it's got 2 bumps on it. A third order frequency means it's got 3 bumps on it. Now, I'm going back to the size of the tire. Let's say that your tire was 10 feet in diameter, 528 times in a mile. All right. How many times does your tire roll over in a mile at 60 miles an hour?
I'm not math.
528 times. Duh. 60 miles an hour. Okay, so you're going to take 528 and divide it by 60, aren't you?
Sure.
Okay, so what's 500? Branden, you got a cell phone? Don't say you don't, because I know better. I've seen you text me. 528 divided by 60 is what? Huh? 8.8? My goodness, look at here. That's pretty close to what we're seeing right here, isn't it? Now, we don't know on this one here about the LT215. All right, I'm gonna do something here. I'm gonna show you guys something that's real cool. How many of you guys have been to my website?
Not
You
me.
got a website?
How many of you have done the wheel calculation? How many of you have done it? How many of you have done the the calculation of, let me show you this. Watch this. We're going to figure something out now. All right. We got tire size calculator. I got a tire size calculator on my website. The website is coming up on the screen. We are in the tube 5x5. You know what that means, don't you? 5x5. Somebody says 5x5? Now, if you're a helicopter pilot or something, you'll know that means you got good communication. Right. Or if you watched Aliens, you heard that pilot on that thing say that. We're in the tube 5x5 when they were going down. All right, you see this? What's the tire size calculator? Watch this. Tire size calculator.
Might have been to this.
Load it. There you go. Bingo! Is that cool or what? Now watch this. We're going to go on our powertrain fundamentals test. We got a LT215 85R16. Okay? Right? Okay, original tire. LT. Okay, we're going to go 215.
What's the AR?
85. And what was it? R16. Right?
What does
What?
aspect ratio mean?
That has to do with the this versus that. See? We'll talk about that a little bit more later. All right, 16. All right. Got that? All right. Now then, you got, that's metric or standard? That's actually metric, which is what you see most of them. Okay, let's do the upgrade tire. Okay, wait a minute. Back up. Look right here. Never mind. I've got this right here. What is the tire circumference? Somebody do a calculation. Look, let's go to standard measurements. You want to do that? Oh, crud. Oh, there we go. That's it. Yeah, it's the same one. Tire circumference is, no, they're still giving us millimeters. I was trying to get that to change over. I won't do that. And that's my own website. What can I say? All right. Somebody, 2,425 millimeters is what? Somebody found it. 2,425 millimeters is what? Huh?
What do you want to turn it to?
I want to turn it into feet.
Let's see. Turn it to centimeters first, and then
2,425.
1 centimeter is 0.4 inches.
Conversion calculator. We're going to make it happen right here, y'all. Choose a
Would
time.
it be 202.8?
Well, let's see. What was what was it? We got,
You divide it by 30 and get a rough estimate.
you're pretty
of
sure.
feet.
2425. 2425 millimeters is 2.65 feet.
That's yards.
Huh?
Those yards.
95 inches. Yeah, 95 inches. No, excuse me. 7.95 feet. Okay, that's the size tire we got. We found the size tire. Okay, now we got to do some more math. Okay, how many times at 7.9? Let's round it to 8 feet. Make it easy. How many times is that tire going to roll in a mile? 5,280 divided by 8 feet. Somebody throw that at me. Do it. Calculator people, come on. 5,280 divided by 8. 5,280 divided by 8. You can use a calculator. Everybody's got a calculator on their daggum smartphone.
660.
Huh? Okay, 660. Okay, back up now. Now look, we're going to find the answer to this question, and we're going to figure out. We're not in here just to get through with the class so we can get the Sam Hill out in the shop. So we're trying to learn something while we're in here. 660. Okay, now then, we're going to divide 660. We're at 60 miles an hour, right? 660 divided by 60 seconds is what?
660. That would be 11.
I'd say that C would be the right answer, wouldn't you?
660 divided by 60 seconds.
12.
Huh? That'd be 11 or 11.4.
Roughly 11.
All right. There you go. 11.4. All right. Everybody happy with that? Everybody think that you might have an opportunity to use that. Now, on my AskAMechanic.info website, that tire size calculator is really, really handy. Okay. All
Ask
right.
the mechanic.
Huh? AskAMechanic.info. AskAMechanic.info. A truck with LT 225 60R16 tires is traveling at 60 miles an hour. If it has an axle ratio of 355 to 1, which of the following is closest to the prop shaft frequency? My goodness, this gets deeper, doesn't it? You understand noise, vibration, and harshness? Take somebody that's a little smarter. Let somebody that thinks that you send the dummy that couldn't do math down to automotive because he ought to be able to get bust knuckles without having to do math. Hey, we're looking at noise, vibration, and harshness. You better know some algebra and other things too, right?
Guess this one Dave will quit.
Huh?
Guess this one Dave will quit. He wasn't good at math.
Yeah, he was a wuss.
Forestry math was pretty hard.
Huh?
Forestry math was pretty hard.
Oh
It
yeah,
surprised
I mean
me.
anything. You'd be surprised how much
I
math.
hate forestry math.
Yeah, forestry math. Did you have to do that already?
No.
Was that good? All right. Yeah, how many board feet of lumber do we have on this tire here? Okay, no, I'm kidding. LT 225, 60R16 tires, traveling at 60 miles an hour. If it has an axle ratio of 355 to 1, which of the following is closer to prop shaft frequency? All right, now look at this. We got a slightly different tire, so we're going to need to recalculate, right? Can we do that? What's that size tire again? 225?
225, 60R, 16.
225, and this is a 60, and this is an R16. Okay? All right. That's the original tire, right? Okay. Now then, original tire is the tire circumference. Now listen to this, you guys. 97.39 inches. Got that?
It's about 8 feet.
Yeah. 97 point, 8 times 12, 96. So that's 8 feet, isn't it? Right? That's about 8 feet. Okay, now, wait a minute now. You're going, how far is that now? That was 66, wasn't it? It was slightly more, though. It's slightly bigger. 97.39. Okay, somebody give me the 5,280 divided by 97, divided by 12 inches. 12 inches into 97.39. He's about to die over there, isn't he?
Yes, I am.
Yeah. He shall not surely die. Somebody tell me. I'm waiting for an answer over here.
Brandon's doing it.
97.39.
He's taking at least.
Huh?
He's into it again.
8.15.
How about 8.15?
Yeah.
Okay, 8.15. Now divide 5,280 by 8.15.
647.85.
647.85. Okay, now you're going to take, say that again now?
647.85. So
Okay, now divide that, now divide that by 60.
$10.79.
All right, now you're going to multiply that times 3.55. Because that's your axle ratio, right?
38.33.
38.33. Everybody come to, we think we did that right? Why?
Whatever.
Wait, what was it?
Because there's not one. So it's not.
Actually, according
I've
to
never seen Brandon move that fast.
Actually, according to the answer key, I've never seen him move that fast either. Actually, according to the answer fee, is 46. According to the answer key. So we did something wrong. Now, every time we go through this, every year when we go through this, we wind up getting a little bogged down in these numbers and all that. A vehicle's six-cylinder engine is running at 2,520 RPM. What is the engine firing frequency in hertz? Now think about it. A hertz is per second. Okay, so revolutions per minute. Okay, so what's 2520 divided by 60?
25, 20.